Hello, this is Elizabeth back from the Raritan Valley Community College Academic Support Center. And we're just continuing to work through the Pre-Calc 2 review. So question 6 gave us this point, 7, -8, and it wanted us to find, what do we want to find? We wanted to find cosecant of that angle. So in order to find cosecant of that, we need to have this third side of the triangle. I like to draw it whenever we have a point, we can draw a line from the origin to the point. If we drop a line straight down from the x-axis, this portion here is going to be our x value. So this portion here is going to be 7. This portion here is -8. How much we go down is -8. So we can find the length from our origin to this point using the Pythagorean theorem. So 7 squared plus -8 squared is equal to c squared. So this is 49 plus 64 is equal to c squared. So 49 plus 64, that's 113 equals c squared. So c is equal to 113. So this is square root of 113. Square root of 113. So now we can find the cosecant. Cosecant is equal to the hypotenuse over the opposite. So that's going to be square root of 113 divided by 8. The 8's negative, so this is going to be negative. Whole thing's negative. Okay, that is 6. Moving along to 7, we have sine of theta is equal to -1/5, and tan of theta is less than 0. And we are looking for cosine of theta. Again, sine of theta is negative. That's going to put us in quadrant, if we have here. That's going to put us in quadrant 3 or 4 down here. But tan is less. Okay, calculus. Tan is less than 0, so tan is positive in 3. So we're in quadrant 4 over here. So I like to draw triangles. This is -1/5 is sine of theta. So this is theta. This is -1, and our hypotenuse is 5. Okay, so in this quadrant here, we're in quadrant 4, so our cosine is going to be positive. But to find our cosine, we need our adjacent, so we need this side. So we have, if this is x, we have x squared plus -1 squared is 1 is equal to 5 squared is 25. So x squared is equal to 25 minus 1 is 24. X is equal to the square root of 24. We can write this as the square root of 6 times the square root of 4, and the square root of 4 is 2. So this is 2 square roots of 6. So this x is equal to 2 square roots of 6. So now we can evaluate cosine of theta. Cosine of theta is our adjacent over our hypotenuse. So this is 2 square roots of 6 is our adjacent, and our hypotenuse is 5. So that's cosine of theta. Okay. Number 8, I think I put up here, sorry. 8. Okay, so we have cosine theta is equal to -7/8, and we know that theta is between pi over 2 and pi, so that means that we're in the third quadrant, and we want to know what tan of theta is. So again, we need to find that third side. So I like to use pictures. Some people like to use the Pythagorean identity to find sine of theta, and then you can divide. But so -7/8, so we're kind of like 8 is our hypotenuse, and this side is -7. So we need to find what this x is. So again, we're just going to use Pythagorean theorem, we know -7 squared plus x squared is equal to 8 squared, or this is 49 plus x squared is equal to 64. We subtract 49 from both sides, we get x squared is equal to 15, or x is equal to the square root of 15. So we can label this up here, square root of 15. And now tan is our opposite over our adjacent. So our opposite is square root of 15, and our adjacent is -7. Okay. Number 9 is graphing of a sine function. So I wrote all of this stuff over here. So we have this function that's 1/2 sine of x divided by 3 minus pi. And we have, this is our standard form for our sine function. We have a out here as our amplitude, and we have b and c in here. And our phase shift is c over b, and our period is 2 pi over b. I'm going to rewrite this equation just a little bit so it looks slightly more like that. I'm just going to pull out the divided by 3. 1/2 sine of 1/3 x minus pi. Okay, so our amplitude, our amp, is always a coefficient that's out front. That's our 1/2. Okay, our phase shift is equal to our c over b. That's our pi over 1/3. But when we divide by a fraction, we can multiply by its reciprocal. The reciprocal is 3, so this ends up being 3 pi. That's our phase shift. So that's where we're going to start our graphing our function. That's going to be like equivalent to where our origin was, is at 3 pi. Now our period is 2 pi divided by 1/3. And again, when we divide by a fraction, we can multiply by its reciprocal. The reciprocal is just 3 over 1, which is just 3. So 2 pi times 3 is 6 pi. Okay, so now what we want to do is we want to find some points. Okay, so we're going to always start at wherever our phase shift is. So our phase shift is 3 pi. And sine always starts at the origin. It starts at 0. So that's going to be our 0 point. Now, our period is 6 over pi, but we want to move up by 1/4 of our period. This is 1.5 pi, is 1/4 of our period. So we want to add 1/4 of our period to this 3 pi. So we add 1.5 to that. We get 4.5 pi. Now here we're going to be at our amplitude. Usually sine at 1/4 way through would be at 1. Our amplitude's 1/2, so this is going to be 1/2. We're going to add another 1/4 period. That's 1.5 to this. This brings us to 6 pi. Halfway through our sine function, we're back to 0. Going to add another 1/4 period, so this brings us to 7.5 pi. And now we're going to be at the negative of our amplitude. This is going to be -1/2. And finally, again, we're going to add another 1.5 pi to this. This brings us to 9 pi and back to 0. So now we have these points, we can graph this. And I'm going to try to just draw a graph over here. We're going to have 1/2 and -1/2. I'm going to try and go in increments of 3 pi. Because it wanted us to do 2 cycles. Okay, so at 3 pi, we were at 0. 4.5 pi, which is like here, we were at 1/2. 6 pi, we are back to 0. 7.5 pi, halfway between there, we're at -1/2. 9, we're back up to 0. And we can follow this cycle through, up to 1/2, back to 0, down to -1/2, back to 0. So this is our function. Okay, that's our sine function. I'm sure you can draw better than that. Okay, let me just see. We have time to squeeze this very last one in. Where are we? 10. Okay, so we have cosine, the inverse cosine -1/2. So this inverse cosine, what we're really asking ourselves, what we're really trying to say is cosine, we're trying to find an angle. We want to know what cosine of that angle is equal to 1/2. So we want to find that angle on -1/2. When we do the inverse cosine, we have to restrict our possible outcomes. So cosine is restricted between 0 and pi. So we're looking for a number between 0 and pi who has a cosine of -1/2. If we look at our unit circle for that, we come up with the angle is 2/3 pi, right? 2 pi over, yeah, 2 pi over 3. And that's our angle. So again, this is just using the unit circle to find within the top half of the circle where an angle whose cosine is -1/2. Okay. We are available at the Academic Support Center to help. If you have any questions on these, or if you're struggling with other ones, please don't hesitate to reach out. And we also, there are other videos for the problems in the review packet.